Hi all, so this is just really a bit of a precursor to this video. So towards the end of this video, after I got the crankshaft fitted, you'll see I kind of end up sort of coming to a stop. So the reason for that is because I had a chat with Richard from Church House Classics, who encouraged me to use some plastic gauge to check the bearing cap clearances with the bearing shell clearance with the main journal on the crankshaft to check the effectively the diametric clearance between the bearing shell and the crankshaft. So this is, as you know, with the crankshaft, it effectively, once the engine's running, is floating on a sort of film of oil between the bearing cap, the bearing shell, and the actual crankshaft journal. And this should be around when measured. When the journal is you measure it by putting some plastic gauge on top of the crankshaft journal and then torquing down the cap with the shells fitted. And I was looking for a measurement between 1.5 and 2, and I was getting a measurement over 3. So whilst that still would have run, it would have potentially affected the oil pressure over time. I would have had lower oil pressure because a bigger gap, so easier for the oil to sort of spill out from the side of the bearing shell, for want of a better description. So with that in mind, I took the crankshaft back down to the machine shop where I had it hardened. Unfortunately, when I handed over the crankshaft and the rest of the engine bits, I had taken some measurements on the crankshaft and I'd done it with a micrometer, so I thought it was fairly accurate, but I hadn't gone into a lot of detail and I hadn't really taken into account the correct specifications, and I was more looking to see there was no taper or anything like that, which there wasn't. So this engine came with the car. It had been rebuilt, was supplied as a rebuilt engine by the previous owner, but as I stripped the engine down, I soon realised that the quality of the rebuild was hopeless. So, you know, I had to have the heads re-skimmed, I had to have the bores redone because of scratches in the bores. The whole thing needed to be gone through, and the one thing I didn't double check was the crankshaft dimensions in terms of the diametric clearance. So my mistake, and as they say, you live and learn. So yeah, one thing I won't do again is ever sort of take for granted that a crank that looks good and has been polished is actually right. And so my machine shop very kindly have agreed to regrind it for me. They will probably be a charge for that because it's really my fault. However, the good news is the hardening coat that I had done, the hardening layer, should be 10 thou deep, so they don't believe that's going to be a problem because that'll be 20 thou effectively, 10 thou top and bottom, so 20 thou. So if I have the crank reground by 10 thou, I should have still all the way around 5 thou left of hardening, which will be fine. So that's being done at the moment, and when I get that crank back, I will continue with the build. So there you go, a lesson from me to anyone else that's sort of, you know, new to this or starting out doing their first engine build, which this is for me a full build anyway. Yeah, there you go. Every day's a school day.
Okay guys, so I'm now got the rather long-winded task of going through all of the measurements, pistons, piston rings. Now, just turn off the music. So, because this engine's been fully machined and honed and the cylinders have all been done very accurately, I don't really see the need to go and measure each cylinder, checking for out of round and taper and all that. So I have done one just to check, but it's fine. And actually, as the guys at the machine shop pointed out, you know, the more of this you do, the more you're sort of potentially risking scratching the boards, or just even these soft ends on the well, not soft but sort of rounded ends on the bore gauge will mark and will mark the hone. So I'm not going to go mad with that. I'm very confident these guys have done an excellent job. So what I am doing, just for each cylinder, just as one quick check, is I've set this on a micrometer to the standard bore size for the engine, which is in the ROM. I think it's 3 point. Here we go. Yeah, 3.853. So I zeroed this at 3.853, and if I then move you out of the way here a sec, then all I'm doing literally is a very quick check. Is I am just putting a bore gauge on each bore to check that it's what I am over and above the standard. And I'm getting exactly 40 thou on each bore, which is the correct. These have all been bored out to 40 thou, so that's all I'm doing. It's very quick, very easy check, and it's just in case something got missed, but they're all precisely the same. So as you'd expect from a good machine.
Yeah, it's like a handy size, isn't it?
Yeah, it's accuracy.
6 microns to go.
Got the tenth.
It is.
Yeah. 2.5 microns to the tenth. 2.54.
Yeah. It's getting on half a thou, isn't it?
Not really. No, that'd be 12, 13 microns.
They've all been done correctly. So that's all I'm doing in terms of actually measuring the bores. However, on the piston rings, I am having to file these. So, I mean, I've measured them as they came, and actually they're all within tolerance, but they're about as the piston gaps are about as narrow as the minimum. They're basically the minimum tolerance for the piston gaps. So sorry, for the piston ring gaps. Yeah. So about 11 thou and I think 13 thou for the top two with the bottom limit. So that means they're as close together as you'd want them. Any closer and you're risking scratching the bores. When I spoke to the machine shop, they said, look, you know, don't ignore the ROM, but they would always err on the side of caution and go a bit wider on piston ring gaps. So open them up towards the sort of top end of the recommended gap. So widen them, the gaps. So that way you're reducing the risk of scratching the bore. The additional blow by is so minimal, and especially when you've got the rings staggered, they said it far outweighs the risk of a little bit of blow by to have a wider gap that limits the chance that you could have a ring expand and damage the bore. So I'm adopting that process at the moment. I'm following a process that they recommended for filing the rings, which is slightly different to some of the things I've seen online. Obviously online I've seen people doing things like holding a file in a vice and then going up and down like that with a ring. So I've got a high quality engineer's vice, which I'm going to just set up over here quickly to show you. I'll do one. So I'm going to move you back over here. So at the moment I'm just focusing on getting the oil control rings done. I'm opening them up to about 20 thou, which is, you know, wider than the minimum. I mean, with these, the reason I'm doing these first is you can actually, I think they can go up to 55 thou. So there's really no harm in you know, having so trying to perfect the sort of the way I'm doing it using that process. Using this process, I've been using control rings first. So I know that if I put these into the bores, then I get about the minimum, which is about 15 thou for the gap size. I'm opening them up to 20 thou. Oh, hang on. Sorry, I got interrupted then. So yeah, so to file the rings, what I'm doing is using an engineer's vice. What you can then do is you can get the ring just nipped into the vice, and you can sort of almost set the height of the ring, and you can level it out so you've got it nice and even, and you can even drop it down a little bit if it's too much, you think it's going to be too much. So that does away with a lot of the risk of getting an uneven profile. Then a small kind of high quality needle file, or flat file should I say, and then you just working on it on one side only. Then you just release it, give it a little bit of a quick file across to remove any sharpness there, and do the same on the unfiled side. Even though these are obviously new rings, they could have sharp edges, so just take the nose off there. So then all I'm doing then is obviously having to put the ring, move you again, into the cylinder, just putting it near the top because I know that they're parallel all the way down, and then I'm taking my feeler gauge, which is set at 20 thou, and just seeing if I get a nice drag through there. Still a bit on the tight side, so I'm just going to back into the file, into the vise. Just so there's only slightest amount protruding. I got the that side. Just carry on working on the same side. Just take off any sharpness there. Back into the ball. Yeah, and then you've got your gap. So it's a fiddly job. There's a lot of rings to get through, but yeah, that's my Friday afternoon sorted out. So yeah, so that's what I'm going to do. I'm going to keep going. I'm doing the oil rings first, then I'm going to move on to the second compression ring, the second one down, the middle ring, which is the one with a step in it, and then finally the top rings, which are just plain, and you know, open them up to sort of towards the maximum gap size. Okay, that's me taken care of. I'll be back later. Okay guys, so I have done all the piston rings. They've all been filed out so the gaps are the same and accurate. So I'm going with the top ring 16 thou, for the middle ring 18 thou, and for the oil ring 20 thou. That's a slightly different way of doing things from the ROM, and so looking online I've read a lot of stuff about this, and nowadays the view is that the need to the middle ring actually can be more prone to heat expansion, and the reason being is the top ring is cooled by the fuel coming into the cylinder on the intake stroke. So it's the middle ring that can effectively be subjected to more expansion due to heat. And there's also, I think, an element of allowing the gases to flow down through the top ring and then flowing through the bottom ring in such a way that it doesn't compress the gases in between the rings. I don't know. I'm new to this, so I've never built a Stag engine, so this is all new, and I'm just going by a lot of information that I've absorbed and some very knowledgeable people, specifically the local machine shop that I work with, Maynards, who did all the work on this engine for me. And yeah, these guys know what they're talking about, so I think I'll defer to them. All these are new pistons. These are county pistons, set of con rods that I got from Faversham. These have all been these are all were actually new old stock, and they've been the machine shop have already checked them all and honed the small ends, so they've all been resized to the gudgeon pins in the pistons, and the bottom ends have all been checked for roundness, and everything's as it should be. Everything's been balanced, so all of these rods have been balanced and measured and weighed. In fact, you can actually see where they've had a little bit of where they've had to sort of correct the weights, match them all up. So I've got them set up in pairs at the moment as to how they would go in the engine. So with the pistons, you've got the two machined faces that effectively face each other. So once they're on the crankshaft, they'll be like that. So you get two per journal, and those are the two faces that will then interact. The easy way to actually identify these, because they do look very similar both sides, but there's a much bigger chamfer on the side that faces that faces the engine side, if you see what I mean. So with a smaller or no chamfer, those two face each other like that, and then the chamfered face outwards towards the block. So that's all laid out there. So they're ready to go. I'm just going to clean everything up. Each of the pistons has been weighed and matched with a pin. So they've actually given me a kit colour coded here, but they're basically you've got your 8 colours. So every pin is coloured to the piston with a paint mark as well, so it's easy to identify those. So what I'm going to do next is I've just got the hot water tank, the cleaning tank heating up, and then I'm going to give everything a clean and start to build up the 8 pistons with the con rods and the rings ready to go into the engine once the crankshaft is in. So I've got the crankshaft down here, that's going to get cleaned up as well, and then after I've done this, I'll move on to the crank, get that in, and then dial gauge the end float on that and make sure that's right. So that's the next bit. So I'm just going to go and clean these parts, and then I'll be back. Right, okay, so just putting the pistons together. So I've done 2. Thought I'd practice before I showed you guys what I was doing. So I had to pop down to the machine shop actually, because one of the small ends was a little tight on the pin, so I've had that honed quickly. But so what you're looking at really with these, before you start, I'm just checking. I've checked these to make sure they're all round. There's no kind of, so using one of these measures, you can easily just check just to see if they, if they've gone out of round. But obviously, I'm pretty confident these won't be a problem. So that's all fine. Next thing I'm checking is I'm just putting a little bit of oil on the assembly pin just to initially just make sure it's going to fit the piston, the small end of the con rod, sorry. So you're looking for a nice smooth fit like that, so that it just holds itself in place, but there's no kind of play in the pin, which there isn't, as I would expect. So that's good. Everything, I then clean it all off, give it a good old dose of the parts washer, just to make sure there's no bits and pieces on there, because these have been sat around for a while. I'm just putting a bit of oil in there, just not for the moment anyway, but just. And then it's just a case of making sure you've got the rod the right way around. So I'm lining all of these up. So this is the front of the engine. So that's 1, that's 2, and then working my way back to the rear. So this is upside down. So effectively, you know, obviously the crankshaft's going to be at the bottom of the engine, but this is just the order in which the pistons are going to be and the conrods are going to be. So so I've done the first 2. So obviously we know that that's going to be facing forwards in the engine, up against the journal, whereas that is going to be facing the other piston, the other conrod. So that's your without the chamfer there. So so effectively, the arrow on the piston needs to be facing forward to the front of the engine. So I place that down there facing forwards. Got the conrod. Put a bit more oil in there. Can't put too much of this in. This is an assembly oil, and then likewise I've oiled the piston as well. Let's put a bit more in there because I can't remember how much I've done. And I've oiled the bit on the rod. Be a nice sliding smooth fit, no binding. And then just push it through. Yeah. So that's in place. Then got the 2 circlips to go either end. I'm looking at these circlips, they're pressed on one side and then it's like a flat machined face with a sharp edge on the other. I'm having that facing out, so it's pushing against the inside of the groove, because I think that makes more sense to me. I can't find much to suggest if there's any right or wrong way, but that just made sense. So then just a case of putting in the clip, making sure it's in properly. Just I sort of tend to just swivel it around a bit. Yeah, that seems fine. And just push the pin flat up against that. So you can do the other end. And I'm putting the opening of the clips towards the top of the piston. There you go. So that one's done. Just keeping everything totally clean. Getting these done, and then I can stick them to one side while I focus on the crankshaft. So that then is going to be what? Cylinder 1, cylinder 2, this will be 3, and it should be that way round. Okay, and then I'll just do the same again, number 4. So then just quick check, just in case. And all I'm doing here is I've set this to this gauge. You can use as a bore gauge. Get hold of, lock it in place, and you can sort of see how much movement there is. And as you move it around, you can do the same. And you can see that goes around it all the way around. It's the same sort of slight drag on it, but no sign of any ovalness in the big end. Happy with that. So that one there. Now just grab a piston on making a note here which one's which. So white is going to be number 4. So each of these is marked with a white dot on a coloured dot on the piston itself, and then a coloured dot on the matching pin, because the pins are all balanced to the. It's quite difficult to get out. Just out we go. Okay, so just give that a clean. I mean, everything's very clean anyway. I'm just being doubly cautious, and then once it's done I can just stick it out of the way and cover it over so it stays clean. Okay, so let's clean that. Pop over to the parts washer and quickly clean these two. Back in a sec. One rod. And one piston. Nice bit of clean cloth. That. That's all clean. It's all clean. So, right. Next, piston ring. So I prefer. I've tried using the tools that you can get. I just find it easier to do this by hand, to be honest. If you're careful, it's, I think, the least risky way of breaking a ring. So this is the part of the oil ring, and I think the idea is that the join here should always go at the butt, so at the base, so opposite the opening in the ring. So first thing I do is put that on here. And then just push that together. Like that. So that's set there. And then I just tend to use my fingertips, which on the oil ring it's relatively straightforward. It's a bit painful on the compression rings, and then you're also trying to get it over without splitting it apart too far, because it will break. Very delicate items. So that one's on. Everything's located correctly there. When it comes to putting these into the engine, you do have to arrange the rings away from the thrust side of the piston. Right, so all the pistons are done, all the rings are on, everything's laid out here, ready to go into the engine. Just need to set the piston ring gaps to the right orientation. So that's all done. I'm going to cover that over and keep the dust off it. And then we've got this right, there you go, so that can stay in here. Then we've got this, so this is a balanced crankshaft. It's been I think it's 20 thou, but I'm going to check that. I know the shells say that, so 20 thou grind on it, all polished, and then yeah, balanced and nitrided or hardened, hence why it's black. And the way you can check if a crankshaft has been hardened is, first of all, you should see that if it's been done. The other thing you can do is you can take a diamond file like that one, run it over it, it doesn't touch it, so you know that's been done properly. So that's a balanced nitrided crank ready to go in the engine once I've given it a clean up, and that'll be job for tomorrow. I'm off to the pub. Hi guys, so following on from yesterday, I finished the pistons. They're there. Got the crank out ready to just check over, although this has all been put through the machine shop and tough rided, but I will just quickly check the journals and the domains to make sure that the dimensions match up. I'm sure they will, but before I do that, the first thing I'm going to do is give the engine another good clean, because it's been sat around for a week or two now. I've had the heads on and off it a couple of times, so the process I'm using is I just use something fairly non-invasive, so a bit of WD-40 I find works really well, and I bought a few packs of these lint-free towels, which, you know, are really nice, good quality, so, you know, and you just don't risk ending up having a cloth which you think is clean but maybe have picked up a bit of dirt or something doing any damage. So I'm going to put you in the tripod, but, you know, it's not going to be a case of filming me clean 8 cylinders, but I'll just start the job and then yeah, and then spin the block over, and then it's time to look at putting the crank in. Okay. So unfortunately this is where having a pair of Christmas hams for hands doesn't really help. I can't really get my hands down in the bores, but I can just, but not really easily, so it's a bit painful. So what you're looking for is nice clean cloth at the end of it. So you can see there's still a bit of dirt in there, probably from when I was putting the rings in to measure the gaps, as much as anything else. But oh, I can just get my hands in there. I need smaller hands. There you go, so it's still quite grubby, so I'll get another clean cloth and give it another going over. Probably need to do a couple of cloths with a bit of WD for each cylinder. A bit better. one more go, and then that's going to be done. Right, that's 2 down. So I'm going to keep you sat here while I do the rest, but I'll turn you back on in a minute. Right, okay, so before I go any further, I've got the shells here. So these are the shells for holding the crankshaft in, so these are for the mains. You've got your 4 skinny ones, and then obviously your thicker, your fatter ones. So you've got 5 sets in total. So before I go any further, 5 pairs in total. Before I go any further though, just want to make sure that everything's clean here. So these pipe cleaners are brilliant for going into crankshafts, and so you can see here the oil, how the oil flows. So the oil gets fed in here, it flows up to this number, to be number 1 and number 2 on this journal. So you can get in there with that, then it goes from there and it goes, oh, both got to there, okay, that's fine. So both journals go up to that. So that first one there. Then we have this one here, which will go up to the second journal, which, or second and that, so that's piston 3 and 4 on here. So it's good to get in there and give it a good clean out. They all look very clean, no dirt coming out at all. Okay, on this one, obviously what happens there is the oil way comes from the second main bearing up to this journal, which would be number 3. So that's where number 3 piston would go. Then number 4 comes down to this third journal, and then we're going for number 5 also comes up to the other side of this journal, of this main, and then this one will go down, I suspect, yeah, and come out the other side of that main, so that's there. And then I guess these 2 will come down to here. Let's see, like it did at the other end. There you go, 1 and 2. There you go. So they both come to the front. So you've got the 2 to the front, 2 to the back, and then the others in the middle. Use a combination of these. Right, so now I'm just going to get the airline and blow out any dust. Make sure that's behind. Okay. Right, there you go, so that's all cleaned out. Let's give it a wipe down. And the old WD-40 into the top. It's dirty. Worth a clean. So these would have all been polished anyway and prepared at the machine shop and checked for obviously if I was just rebuilding an engine that hadn't been machined, there'd be a lot more work involved. But thankfully this has been machined, and so it's actually fairly straightforward. It's more just checking, cleaning and following the stages. Easier if I had a V block, a pair of wooden blocks to do this on actually, but I haven't to hand. Keep going until you've got a clean rag. Fair amount of dirt still coming off, mainly off, actually not off the bearing faces, but off the actual journals, but off the counterbalances where they terrified of dropping this on the floor. That would just make all of this day go very badly. So a hardened crank, to replace a hardened crank, you're looking at that's part of 800 quid. You buy one from one of the regular suppliers. Obviously I paid to have this one hardened after checking it, which still cost several £100, so it's worth it though, I think. Lots of tales of woe with unhardened cranks, especially in Stags, with those skinny little bearings which aren't really ideal, but you know, people are getting 100,000 miles out of an engine before a rebuild, so I guess it can't all be all bad. Right, that's certainly a lot cleaner now. A few fibres from the cloth still hanging around. Okay, happy with that. Wow. So, next thing is to get these bearings open. These laid out, just make sure everything's right. So they're all the same. They've got oil holes on both faces of bearing, even though you only need it on one, but obviously people can make a mistake, so they just avoid that happening by having all the bearing shells with an oil hole. And obviously you're making sure that those all line up. The tabs make it fairly straightforward, but yeah, so right, so next I am just going to take one little measurement off that. Just double check it. So this is one of my collection of vintage Moore and Wright micrometers, and I keep an eye out for these on eBay, and when I get one I take it down and check it at the machine shop and put it on, you know, use the anvils that they have down there to check that it's accurate, and they're just so much better than some of the modern stuff. Probably the wrong size. Yeah, I'm just doing the mains for the moment, so just kissing through there. Right, so those are measuring 2.2 2.1 for 2.1, well, 2.15. 2.15, is that right? 2.15. Yeah. So 2.15. Let me just go and check that. Yeah, 20 thou. So on the ROM, sorry, I'm not really going into a lot of detail. I probably should go into more detail with it. So 2.15 is what I measured. So that's 2 inches and 150 thou. So if you look at the original dimensions, so for the journals, the mains, which is what we're looking at the moment, 2.1260 to 2.1265. So if you then take that number away, I chose the 2.1260 from the 2.15, you end up with 25 thou. If you take away obviously the 2.1265, which is the, again, within tolerance, then you get your 20 thou. So they're definitely 20 thou on the mains. And just check they're all the same. So leaving the micrometer set. Yeah. 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 Okay, so they're all bang on. So that's those checked. We'll do the same with the crank pins before we put the crank, once the crankshaft is in the engine. I need a slightly smaller. Right. Yeah, so we'll check the crank pins because they need a 1 to 2 inch micrometer, which I have got. Just no need to pull that out to put the to get the crank in the block. So first things first, I'm going to place the bottom shells in. Start with the 2 thin ones. Move you over here. the engine a little bit that way. Okay, so obviously you've got the tabs on the shells. I'm not going to put any lubrication beneath the shell because obviously all the lubrication is going to be there you go, they're nicely centred. You can see the holes are lined up there. You just needed a little bit of pressure to push them in. Wrong shell. That's a thicker shell. Thinner one should go here. Sorry. Just thinking I did it right. Okay, so that's that one lined up. And there. And then we need 3 of the larger ones. That one. So I'm just putting the tab in. The easiest way to squeeze, just put the tab in, hold your finger on top, stop it sliding back up again, and then just push down on the opposite side and then level them out so that you can feel that they're level. Obviously, once you put the crankshaft on top and put the other shells and the caps on, it'll all sort of bed down anyway. So all the shells are on now. For the bottom shells are on. Just gonna double check the dust on those, and then a good coating of oil, assembly lube. That's it. So I'm hoping I can get this in without any problems from the. So just drop it down. Okay, there you go. It's in. So what I'm then going to do is just put some more assembly lube on the top of the journals and give it a quick twist round just to make sure that it loads in there. I'm not going to skimp on. There you go. It's very oily. Right. So at the moment, crankshaft's in, but as you can see, you've got a lot of back and forth movement here. And that's where these thrust washers come into play. So these need to be mounted with the copper coloured bimetal face is against the rotating surface. So you've got two. There's one One goes on this journal on this side, and then the other one goes on the other side. So they're basically either side of that centre journal, and so you want, you want the silver side facing towards the block, and the copper side facing the machined surface of that journal. And you can see there, if you look closely on that side, you've got that thicker sort of machined surface, which is where they go against. So coat of assembly lube, and then it's simply a case of putting it in place. The right way round. And then just pushing it around, and then you can see that's in place now. Then you've got the other side. So this one will go facing forwards towards the journal, whereas this one went back towards the journal the other side. They just slide in like that. There you go. So you've got the copper facing that way and the copper facing that way. Now that would have taken out a lot of the play, but there is supposed to be a certain amount of end flow. And I can see that there is. So at this point we'll just measure it. So the way that's done is you measure front of the engine. You're literally just looking to get your micrometer on the front of the crankshaft. Okay, so switch it on, zero it, it's very hard to zero this because every time you touch it. There you go, zero. Right. So if I pull back, I'm getting a little bit of negative. So I'm going to pull it back as far as I can, then zero it again, and then I'm going to push it forwards. So that's 9 thou. 9.5 maybe. So get the book out. And what does it say? End flow 0.003 to 0.011. So we're at 0.009. So we're within tolerance. We're within tolerance, so happy with that. may just try with a little bit more. Okay. Arguably 10 thou, but certainly no more than that, and still within tolerance. So 50 to 65 foot-pounds, main bearing caps to block, 65 foot-pounds, which size from that. 65 foot-pounds. Foot-pounds. So I'll bring them down stages. Still nice and smooth. Doesn't give you any kind of specific order of talking on these. I think you're just supposed to tighten them up, but I'm just going to keep going on what I'm doing here. Sort of start building it up slowly. Just checking it's still free to turn. Beautiful. Getting close, I think. Still recording. Beautiful. I think this is going to be nice and smooth. Okay, so I've taken them all to 65 foot-pounds. So I've gone for the highest torque spec. I don't understand why you wouldn't do, but hopefully now that's going to be smooth. Look at that, it's like butter. Beautiful. So there you go. Crankshaft is now in, and yeah, happy with that. It's gone very smoothly, other than some mistakes that I made. But now the next stage will be fitting pistons. So in the meantime, I'm waiting for a piston ring compressor. The one I had was pretty gnarly, so I've ordered a new Sykes Pickavant one. So that should be here on Monday. Anyway, there you go. So crankshaft is in, torqued up to 65 foot-pounds, which is the top of the range that they advise, and as you can see, that is beautifully smooth. End float set at about 8 to 9 thou, 8.5 thou, something like that. So well within tolerance there, and yeah, very happy with all that. It's gone together nicely.